Alright, so this is a little video about the rules for congruent triangles, and they're saying rules, but they're also known as postulates. That's the official mathy word for them, is a postulate. And so a postulate is just something that's assumed to be correct and true. And when we were talking about our congruent triangles the other day, we said that basically what we need to do to get triangles congruent is we need to be able to move them, either slide them, rotate them, flip them, so that one of them matches up exactly with the other one. So in the process of doing that, what we ended up doing, if I get the pen here, was making all the sides congruent. That's the little mark that we use to show congruent. So all three sides are congruent. And all of our angles are congruent. This angle to that one, this one to that one, and that. So by doing this slipping sliding thing, we matched up all three sides and all three angles. Question is, can we get this done with less? And so, let's see what we can do. My pointer, there's the pointer. So here I've got the three side lengths. They are the exact three side lengths, and I've just sort of broken them independently, and I've got them sort of at the angle that I want them to be at. And I really want the pointer, not the pen. So I've got the pointer now, and what I'm going to do is I'm just going to move these three sides and line them up with the triangle. And if the, right now I've got them at the angle that I want them to be at, but I could easily manipulate them if they're the right length. And so by just moving the three sides, I have matched up the triangle. So it turns out that I don't need to do all the angles and all the sides. I can just do the three sides. So this is our first postulate. It's called the side-side-side postulate, and we abbreviate that SSS. If all three sides of one triangle are congruent to the corresponding sides of a second triangle, then the triangles are congruent. And so what that means is that, I don't know, let's go with Jim. Call this guy Jim. I'm going to call this guy Jim. Okay, so it means that we matched this side with that side, we matched this side with that side, and we matched our third sides together. And so the way we would write this, if we wanted to, was we would write triangle JIM is congruent to triangle GYM by side, side, side. Okay. Okay. Let's move forward. So this time what I've done is I've taken an angle, I've taken a side and an angle and another side. And that's all I've worried about. So I've taken a side, an angle, and a side, and the angle is included. It's between the two. Now if I just match up the side, the angle, and the side, is there any way I could make a triangle that's not the triangle that we're looking for? There's no way I can connect this red to that red without it being this black line that we're there. So by just messing with by just matching up the side, an angle, and the side, the ones that are right connected to each other, I've got congruence, which leads me to postulate number 2, which is the side angle side. And that one says if two sides and the included angle of one triangle are congruent to their corresponding parts of a second triangle, then the triangles are congruent. Okay, and so, I don't know, let's call this art, and let's call this, I don't know. I don't even know. Now we're going to call it Jim. We'll stick with that. Okay, so art and Jim. And in this case, what we did is we did an angle, of course, congruent to an angle. We did I just totally marked that wrong. We did a side congruent to a side. And now we're doing an angle congruent to an angle. And now we're doing another side. Okay, so we would write that triangle ART is congruent to triangle GYM by angle, side, angle. Okay, so we don't need all that information. We just decide an angle and a side. What else can we do? Well, it looks like now I've set myself up to do, I've got an angle right there. I've got the side, and I've got another angle. So I've got the angle, the side that's in between the two angles. So two angles in the included side. And if I match that up, like so, is there any way I could complete the triangle without making, without hitting those two sides that I need, basically extending this one up to there and that one up to there? I think not. Okay, so here's a case where all we need to have is an angle, a side, and another angle. And so, if two angles and the included side of one triangle are congruent to the corresponding parts of a second triangle, then the triangles are congruent. So we're talking about angle, angle, side, side, other angle. Okay, and I don't know. Let's call this one Sue. Let's call this one. Okay, and so we would say that triangle SUE is congruent to triangle LAW by angle, side, angle. So we get an angle, then we get a side, then we get an angle. Angle, side, angle. That's how that works. Angle, angle, side, would that work? So let's look. If I have this angle congruent to that angle, I have this angle congruent to this angle, and then I have this side. Could we make that work? Let's stop and think for a minute. I've got a certain number of degrees in a triangle, right? I've got 180 degrees. So if these two are the same, and those two are the same, would it stand to reason that this third angle would have to also be the same? I hear you saying yes. Good. So once we've got that third angle, then we're back to an angle, angle, side situation. Or, I'm sorry, we're back to an angle, side, angle situation, so it would work out nicely. And so we are allowed to use angle, angle, side as one of our reasons, and well, lo and behold, it's right there. Two angles on one side of a triangle are congruent to the corresponding parts of another triangle. Then the two triangles are congruent. Okay, angle, angle, side. Angle, then an angle, then a side. In this case, the side's not included, and I don't just know bow, and I have no idea. I've run out of creative ones. Maybe you were thinking you ran out of them a long time ago. So triangle BOE is congruent to triangle BIP by angle, angle, side. That's how that's working out. Okay, fast forward to the good parts. And does this one work? Angle, angle, side. So basically what I would have, let's just say, I would probably have a triangle, right? I have a triangle here. And then I have another triangle here. No, I don't have a triangle, but I don't. If I had this angle, and this side, and that side, congruent to this angle, this side, and that side, could it work? And the answer is no, because basically what I could do is this, I could swing this side in a little ways. There's a couple of places where this side would match up, and so what it says right here is that we don't have that as a rule. Okay, so we can't use angle side side. It's a bad thing. If we see that on your paper, then you know, all trouble is going to break out. So angle side side does not work out for us at all. All right, so a couple of triangles that we're going to try to prove congruent, and get my pen back and mark some things up. So say we're given a triangle and we're told that I don't know, this side is congruent to that side and this side is congruent to that side. Could we say that these two triangles are congruent? And I'm just going to be totally uncreative and just use A, B, C, and D. Could we? Could we? I think we could. If suddenly we notice that DB is in both of these two triangles, see DB? DB, and that's congruent to itself. And so we could say that triangle A, B, D is congruent to triangle C, B, D by side, side, side. So if we have a common side or a common angle in two triangles, we can use it to our advantage to prove the triangle's congruent. Here's another one. Oh, it's the Christmas music. 3 French hens, 2 turtle doves, and a partridge in a pear tree. Alright, maybe we'll edit that out, maybe we won't. You'll just never know if I did. So anyway, we've got these 2 triangles that I drew in there. I've got them right on top of each other. It's the bow tie, it's the hourglass, whatever you want to call it. I've given you that this side's congruent to that side and this one to that one. Hopefully you recognize that, hey, we could probably just do a reflection and they would match up, so we'd probably be okay. And actually I think the same thing would be true of this one. We could have just reflected over that line DB and matched it up. So, oh, excuse me. One thing we would notice is that this angle right here is congruent to that angle right there. Okay, those are called vertical angles. Until we get angles formed by the x. And vertical angles are congruent, so if we see vertical angles, we can use that to our advantage. And then we could say that triangle ABC is congruent to triangle EDC by side angle side. Oh, excuse me for the cough again. So that's it. We've got 4 rules for congruent triangles. Okay, then I don't know why I drew those. Those seem like they should be on another page, but I'm not sure what's going on there. So if we have side, 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 we have side, side, we have angle, side, angle, and we have angle, angle, side. Those are the ones that work for us. If we can get any combination of those to work, we don't have to do the whole work of like, hey, how do we move this one to that one? So thanks for watching, and we'll be seeing you real soon. Thanks for stopping by.